And question number 9 says a ladder 13 feet long is leaning against a building, and the foot of the ladder is being pulled at a constant rate at 8 inches per second. So I've converted that in green here to 8 inches per second into 2/3 feet per second. And then it asks how fast is the area of the triangle formed by the ladder changing? So we want to know the area of the triangle and relate it to the height and the width. So I've written it here. The area of a triangle is equal to the height the height y times x divided by 2. And what we want to do is we want to generate dA by dt. So I'm going to differentiate this, dA by dt. And using product rule, we're going to end up with dx by dt, which we know, times y, which we know, plus x. Again, we know x is 5. Okay, we work that out using Pythagoras. And then differentiating y, we get dy by dt. Okay, so we know all these parts. We know dx by dt, we know dy by dt, we know y, we know x, but we don't know dy by dt. So what we need then is we need some other relationship that's going to generate a dy by dt. And in this right triangle, that relationship is going to be this. X squared plus y squared equals 13 squared. Okay, the 13 is constant, so we're going to leave it as 13. And then when we differentiate this implicitly, I get 2x times dx by dt plus 2y times dy by dt. And that's going to equal to 13 squared derivative, which is 0. It's a constant. And when we do this, we have x, y, dx by dt, so we can solve for dy by dt. So plugging it in, I get 2 times x is equal to 5. Dx by dt is 2/3 feet per second. The y value is 12. And then we're going to solve for dy by dt to be able to then use it in that to solve for dA by dt. Okay, so I'm just going to do a little bit of color coding here. So that's my x, dx by dt. There's my y, and I'm going to solve for dy by dt. So I get I get 24 times dy by dt is equal to, and then I'm going to multiply that all together, 2 times 5 times 2 divided by 3, so that's going to end up being 20 over 3, and then I'm going to subtract that, so I'm going to end up with negative 20 over 3. Okay, and then solve for dy by dt, and we end up with negative 20 over 72. We can simplify that, divide that. There's a common factor of 4, so we're going to end up with negative 5 over 18 feet per second. Okay, so now we've solved for dy by dt. Our dy by dt is going to be negative 5 feet per second, 5 over 18 feet per second, so we can plug it in there. And so at this point, we have all the pieces we need to solve for dA by dt. So 1/2 dx by dt we had as 2/3 feet per second. The y value we had as 12 plus the x value we had as 5. And then the dy by dt we solve for as negative 5 over 18. And we can work that all out now. So this works out to be 24 over 3. I'm just going to simplify that actually. That just works out to be 8 plus negative 25 over 18. Okay, and then what's that work out to be? I'm going to need a calculator here. So 1/2 times 8 minus 25 over 18, we end up with 3 point, I'll convert that to a fraction, we get 119 over 36. Okay, so we end up with 119 over 36. This is going to be square feet per second.